This was a weird and unexpected development. For years now, astronomers have searched for the very first known exomoon to be discovered with a number of candidates, but no really strong confirmation of something that almost certainly is very common in the universe: moons. After all, our solar system has hundreds of small moons, even orbiting Kuiper Belt objects. And probably there are hundreds more to be discovered. As far as large moons, again, it has plenty, and one of them orbits Earth. It would stand to reason that since we know of thousands of exoplanets, within those systems there are also likely to be moons. The problem is, moons tend to be small, and in most cases we may never know if many of those exoplanets have moons or not. After all, Venus is a major planet, yet it has no moon. So there's a lot of room across the board in this question. That exomoons are inherently hard to detect is why there hasn't been much certainty about candidate exomoons until now. Now, there is a strong one. The problem is, it's unclear if it should be called a moon at all. The star system in question is known as CD 352722, and the new discovery was made by a team of astronomers led by Kevin Hoy using the Very Large Telescope, or VLT, in Chile. Link to their paper in the description below. And this particular system is probably going to force a rethink on what we consider a moon to be, and I suspect this may actually get classed as something else in the end. Indeed, the word exosatellite is already being used here because it certainly is that, if not a classical moon. You see, the exosatellite in question is the size of Jupiter and does not orbit a proper star or planet, rather a brown dwarf. A brown dwarf is difficult to define other than it's a failed star, but that's misleading in that it only means that it lacked the mass to trigger hydrogen to helium fusion in its core. But large brown dwarfs early in their lives during a very short period do actually see some fusion of things, like deuterium. So they are very, very close to a star and do things that planets do not, at least the massive ones. But they don't have the mass to produce the massive fusion reactions of hydrogen, as full-on stars do. That said, a brown dwarf can exist on its own and float through space and even maintain planets, as any star system would. They do not have to be part of a star system in and of themselves, in which case, is a free-floating brown dwarf a rogue planet? Not really. Is it a star system? Not really. Is it a brown dwarf planetary system? Yes. Are planets that orbit brown dwarfs moons or planets? That's the $64,000 question that organizations that name and classify astronomical objects, such as the IAU, will face, especially after this discovery. Here, though, this discovery gets even weirder. This brown dwarf isn't floating in space. It's orbiting a true star about half the mass of the Sun at a distance of about 73 light-years. In a somewhat sad state of affairs, the newly discovered exosatellite, if it were in orbit of the star directly instead of a failed star, it would definitely be considered a gas giant planet. But since it orbits the brown dwarf, that doesn't quite fit. Nevertheless, the researchers are careful to call it an exosatellite and not an exomoon until it can be hammered out as to just what defines a moon at all. So the star system is odd in other ways. So the brown dwarf was discovered in 2011 using direct imaging by a telescope, but the exosatellite was discovered using radial velocity data, basically the tug that a body undergoes as its satellites interact with it gravitationally. But in this case, it was the exosatellite tugging on the brown dwarf that they saw. This is normally something seen in exoplanet hunting. They look for the star of the system itself to be wobbling from tugging. But here, it was the brown dwarf wobbling. There also may be more than one exosatellite involved, one with a mass of 0.743, that of Jupiter, that is on a 169-day orbital period, that's the one in question, and a second candidate with a mass of 0.277 Jupiter masses with an orbital period of 87 days. This star system itself represents a system very different from our own solar system, markedly so, but also has another distinguishing feature. The system is a member of the AB Doradus moving group, which is a group of 30 stars that are associated with each other and are moving as a group with the star AB Doradus. This points to all of the members having a common origin, along with the members all being about the same age, same composition, and the same motion. This means that the stars all probably formed in the same solar nebula molecular cloud star-forming region, but are young enough that the members have not dispersed, as the Sun did with its siblings from its birth cluster long ago. Here the stars involved are probably only between 50 and 150 million years old. For whatever reason, the star-forming region liked to produce low-mass objects. AB Doradus itself is a quadruple star system and contains one of the lowest mass stars we've ever seen, only just barely large enough to ignite into a red dwarf rather than remain a brown dwarf. There's also a strange object in its own right associated with the AB Doradus moving group that was discovered in 2012. It appeared initially to be a free-floating rogue planet, somewhere between 4 and 7 times the mass of Jupiter, but this has since been revised as a very low-mass brown dwarf. Again, the lines get blurred as far as definitions go. Now, this could in principle go another way. I can see the definition of a star being reasonably based on whether it fuses hydrogen into helium. That's a clean-cut distinction. But a brown dwarf definition sort of classifies AB Doradus as the lowest mass type of star, but not a brown dwarf. Okay, but in many ways, low-mass brown dwarfs have more in common with planets. So maybe supergiant planet might be the best term for CD 352722b. I leave that up to the astronomers, but there is a further level to this. It's long been suspected that while we haven't actually seen one, there exists the possibility of a natural subsatellite. In short, physics allows for moons of planets to have moons of their own. These are the infamous moons. One reason we know these can exist is that we make them artificially whenever we insert a spacecraft in lunar orbit. And indeed, the ascent stage from the Eagle from Apollo 11 is thought to still be in orbit of the moon. But with natural ones, we can infer that from our solar system, and the fact that we haven't seen a moon around any of our hundreds of moons suggests that while not impossible, they are rare for various reasons. But this changes when you start getting things up in the range of mass of Jupiter and Saturn. Jupiter has over 100 and Saturn comes in at 293 moons. The bigger the planet, the more moons it tends to have, and that brings us back to CD 352722. So here, the nearly Jupiter-sized exosatellite of the brown dwarf is well large enough to have numerous moons of its own. Think of it in terms of Jupiter. It could have moons like Io, Europa, Callisto, Ganymede, all the way down to tiny asteroid-like moons like our gas giants have. It's also possible for large gas giants to capture asteroids and make them into moons. So this exosatellite may in fact have moons. Unfortunately, it's unlikely we could detect them with current equipment, but even stranger still, such a moon could have a habitable Earth-sized moon. Earth in the evolution of life itself through luck is a planet, but if things had been different, Earth might have been born a moon of something else. But again, the definitions get blurred. There is an exoplanet known as Kepler 1625b that has a candidate exomoon. Here it's not a brown dwarf involved, rather it's actually a planet, though a massive one, a super Jupiter. The moon, if the measurements can be confirmed, there in question, is about the size of Neptune. This one may be familiar to all you science YouTube channel watchers. This is one of David Kipping's of the Cool Worlds channel Exomoon candidates. Unfortunately, it's still an unknown if this is indeed an exomoon due to questions about the data itself, so the issue is controversial and still open. If exomoon is the word you want to use in that case either, and that is also a problem. The problem is that at some point you almost have to call such a scaled-up planetary system a double planet. We know this. People have pointed out for years that in the case of Pluto and its moon, they are close enough in size that they perhaps could better be characterized as a double minor planet. The elephant in the room here, of course, is Earth, in that our moon is proportionally very large compared to the size of Earth. Perhaps large enough to call the Earth-Moon system a double planet, or I would suggest, as we do it in astronomical terms, and term them binary planets, if it goes in that direction. In the case of CD 352722b, would subsolar system be a good term? You tell me. But that means the moons would then become moons in such a system. Lions and tigers and bears, oh my. There have been many other candidates to date for exomoons proper. One is the exoplanet J1407b, discovered in 2012, and it's an exoplanet with a really epic, extensive ring system, like Saturn but on a larger scale. But like Saturn, its ring system features gaps, and in the case of Saturn, that is caused by shepherding by tiny moons gravitationally. The weird thing here is that J1407b, even though it was discovered eclipsing a star, the star appears to have been a background object, and the exoplanet is a large rogue planet free-floating in space. It's never been detected since, when it should have been. Other candidates include another free-floating planet that may have a moon, several hot Jupiters, and many others, but one odd one is a candidate exomoon of the hot Jupiter planet WASP-39b. There's evidence there for the presence of sulfur dioxide. That's a weird gas for a gas giant, indicating that some unusual chemistry is going on in the atmosphere, or alternatively, a volcanically active exomoon depositing it. And that brings us to one final weird classification, a plunet. This happens when exomoons get tidally detached from their home planet, get ejected, and float free. This would be something that happens predominantly during planetary migration periods of star systems before everything calms down. The odd thing there is that it implies that a moon, moon, or exosatellite in general can indeed someday become a planet. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently accusing Saturn of hoarding moons. No planet needs nearly 300 of them, and clearly it did not bring enough for everyone because Mars and Venus sit there with no moons at all, and Earth certainly can't spare its moon. Mars could spare one and lend it to Venus, but then comes the question if Venus would give it back. It's bigger than Mars after all, and what's Mars going to do about it? And be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.